Hello everyone, I am Dr. Samyukta S, Assistant Professor, Department of ECE at SJBIT. In this video, I am going to explain the styles of description, that is a types of Verilog description. A hardware circuit can be described in several ways depending on the levels of abstraction. Designer chooses a style based on the complexity of the circuit and the design requirements. There are 6 description styles in Verilog. The first one is the data flow description, second one behavioral description, third one is the structural description, fourth one switch level description, fifth one mixed type description, and lastly mixed language description. So these are the 6 types of descriptions we have in Verilog. So now let us discuss these descriptions one by one. So the first one is the data flow description. Data flow description explains how data moves from inputs to outputs. So instead of describing the hardware components, we write the Boolean equations for the outputs here. It is mainly using the statement or the Verilog keyword called the assign. So as an example, here I have wrote the Verilog program for half adder, that is module name is half adder, the inputs are A and B, the outputs are sum and carry here. So the inputs are defined by the variable AB, outputs are defined by the variable S and C here. So assign S is equal to A XOR B, assign C is equal to A and B. So these equations are directly written in Verilog. So assign S is equal to A XOR B computes the XOR operation between the variable A and B, and assign C is equal to A and B computes the AND operation between the variables A and B here. So next type of description is the behavioral description. Behavioral modeling describes how the circuit behaves rather than how it is built. So this particular type of description uses two keywords. One is always and another one is initial. So here as an example, I have written the half adder program again. So module name is half adder. The inputs are A and B. The outputs are sum and carry. So as I've told, this behavioral descriptions consists of a keyword always. So here I've written always at A comma B. So always at A comma B means whenever A or B changes, then the block will going to execute. So always at A comma B begin if A not equals to B. If inputs are different, A not equals to B means both the variables are assigned with different values. If inputs are different, then the output, sum output S is equal to 1 bit 1. Else means if both the inputs are same, then the output sum is equal to 1 bit 0 here. So this operation exactly performs an XOR operation. Next type of description is the structural description. See, the structural modeling builds a circuit using logic gates. Instead of writing equation, here we connect gates together. So this description is identified by the presence of the keyword component in the architecture. Gates constructs such as AND, OR, and NOT in the module. So as an example, here I have considered the same program written in this structural description modeling. So here there is a line where AND A1 C comma A comma B here. So here C is the output and A and B are the inputs. Similarly, XOR of x1 s comma a comma b. Here S is the output, A and B are the inputs. So this type of description resembles the actual circuit diagram of a half adder. So the advantage of this type of description is, so this is very close to real hardware and also useful for gate level implementation. So the next type of description is a switch level description. See, switch level description modeling is the lowest level of hardware description. So instead of logic gates here, it uses transistors. So common primitives are PMOS transistor, NMOS transistor, CMOS transistor, transif 0, transif 1, etc. So here in this program, here I have written a program for inverter here. So as we all know, inverter consists of only one input and one output. Here variable A is defined as an input and variable Y is defined as an output. So this particular inverter requires supply here, that is supply 1 VDD, supply 0 ground. Supply 1 VDD represents logic I and supply 0 ground represents logic low. Below that, here we have defined PMOS P1 Y comma VDD comma A and NMOS N1 Y comma ground comma A. So here the PMOS and the NMOS transistor together they form a CMOS inverter here. So this CMOS inverter is nothing but a NOT gate. So coming to the operation, suppose if input is equal to 0. Here if input is equal to 0, then PMOS will be in an on condition and NMOS will be in an off condition. So the output is equal to 1, that is Y is equal to 1. Suppose if input is equal to 1, that is A is equal to 1, then PMOS transistor will be in an off condition and NMOS transistor will be in an on condition, so that the output is equal to 0, that is Y is equal to 0. Thus Y is equal to not of A. This is how the program will going to work. Next type of description is a mixed type of description. So mixed type modeling combines two or more modeling styles. The name itself suggesting you that it is a mixed type. So as an example, it can mix data flow with behavioral style, or structural with behavioral style, or structural with data flow style. That is, it can be data flow plus behavioral, structural plus behavioral, or structural plus data flow. So this type of modeling combines two or more modeling styles here. So why we have to combine the modeling styles? What is the use of combining the modeling style means? Here large digital systems are difficult to describe using only one style. That is the reason why they are going to use this mixed type of description. So as an example, if I consider the CPU consists of ALU, registers, logic gates, etc. So here ALU will follow the data flow description, registers will follow the behavioral description, whereas the logic gates will going to follow the structural descriptions. So most real world VLSI designs use mixed modeling. Next type of description is mixed language description. So mixed language modeling allows designers to use Verilog, VHDL together in one project. This is useful when reusing existing IP blocks written in different HDLs. So here I have written a program. Here the full adder is written in Verilog, uses a half adder written in VHDL. So this statement initiates the VHDL half adder inside the Verilog module. The statement is HA, H1, Y, comma, C, comma, S0, comma, C0. So this particular statement will be initiating the VHDL half adder inside the Verilog module. So you can see half adder program in this particular style. So this VHDL module can be called from Verilog in mixed language projects. Lastly, ports. Ports connect a module to the outside world. There are three types of ports: input ports, output ports, and in-out ports. So here the input ports receives data from outside. Example, input A comma B. Inputs can only be read here. So output ports sends data outside the module. For example, output sum. Outputs holds the result produced by the circuit. And lastly, the in-out ports acts as both input and output here. For example, in-out data used for bidirectional communication. So as an application, I can mention RAM data bus, microprocessor buses, etc. So this is about the different types of Verilog descriptions and ports. Thank you.